4 identical jars are filled with different gases. The lids are taken off the gas jars and they are left open to the air for a few hours. Which gas jar will then have the most air in it? Of course, if you want the air to get in, the gases inside must be able to escape out of the gas jar. And if you want the gases to escape out of the gas jar so that air can get in, so the gases inside each of the respective gas jars should be less dense compared to air and must be able to diffuse out much quickly. So how would we determine that? For most air to enter the jar, the gas inside the jar must diffuse out at the fastest rate. So the least dense gas, that means the ones with the lowest MR value, would of course end up diffusing out at the fastest rate, isn't it? So let's work out the MR value for each of the gases in the jars. So for nitrogen, relative atomic mass of nitrogen is 14 and it is a diatomic molecule. Twice of 14, it's going to give you a MR value for nitrogen as 28. So if you look at oxygen, it's going to be 32 because each oxygen is 16. So 2 oxygen is going to give you 32. Ammonia is 1 nitrogen bonded to 3 hydrogen. So nitrogen is 14 and each other hydrogen is 1. So 3 times 1 is 3. So that's going to give you a total relative molecular mass of 17. And as far as sulfur dioxide, sulfur is 32, each of the oxygen is 16, so 2 oxygen is a 32 plus another 32, and that's going to work out to 64. And of course, if we compare all the 4 gases here, so ammonia is the lightest or the least dense, and of course, being the least dense is going to diffuse out very quickly, and that's going to be the fastest gas to get out. And of course, the fastest gas to get out will be the jar in which most of the air would get in. So which jar will then have the most air in it? Of course, the jar with the ammonia will have the most amount of air inside. So therefore, the answer is option C.